Okay, yeah, this actually works. So, as he mentioned, my name is Jānis, and I'm a software engineer at Diatom. And before we actually start, I would like to ask you a favor. And the favor is you're gonna make my grandma proud. So can we put all our hands up in the air, please? Yeah. All right. GDPR for. Thank you. So, are we ready for the last push before we actually go to converse and to the party? All right. All right. What is Elm? Well, Elm is a purely functional, immutable, and domain-specific language. That's quite a mouthful, but I'm going to explain all these concepts during this presentation, but I'd like to focus on domain-specific language part at the beginning. So domain-specific because it only compiles into JavaScript and it only works on browsers. So it's sort of a mix between a language and an architecture. And the architecture is like Redux-ish, I might say. So, and the main selling point of Elm is actually that it catches all possible runtime exceptions. And its syntax is really inspired by Haskell, OCaml, and ML. So to begin, I'd like to ask a simple question. So how would a language without runtime errors look like? To start, let's consider such a thing as a partial application. So how would you write that in JavaScript? These first two functions actually are the same. One is in more ECMAScript 6-ish syntax, and first one is for people who might not be familiar with this syntax. And basically, it's a function that accepts a single argument A and returns a function that accepts another argument of B, and basically sums them up as a result of the last function. And now the question is, why would you want to do such a thing? Well, this actually allows us to postpone execution of the function until we actually want it. So we have this add5 function at the bottom where we have add parentheses 5. And we can call it a separate name and pass it around our application. And when we need to add another argument, we are free to do so later on in the execution stack. So that's quite a cool feature. And Elm actually does this by default. So the first thing that you notice here is that we have a type signature at the top. We know that this function accepts an integer, another integer, and then it returns an integer. So, and another weird thing about Elm that it doesn't have any parentheses or commas or nothing like that. So, add is a function name, and A and B are the arguments. And everything that is like the last statement in the function is the return value. So here we see like add 4, 5, it returns 9. Simple, right? So the interesting thing is starting to happen when we in the next function where we say add 5, and it doesn't execute it until we supply another argument. So the result from add 5 will be another function who will expect an integer and return an integer. So in computer science, function composition is an act of or a mechanism to combine simple functions to build more complicated ones. Now, how would we do something that takes a string, reverses, and repeats it? Well, the most naive way to do that would be to write it this way. As we know, like from math and from programming, everything that is in the parentheses will get executed first. So string.repeat to text will actually repeat the text 2 times. And the result of that will get passed to string.reverse. The next, the more better, I would argue, implementation would be with a pipe. So string.repeat to text will get passed to string reverse. So everything that is on the left side, the result of that computation will get passed to the right side as the first argument. So actually, this is the most interesting way to solve this, to make this happen. So because Elm is statically typed, we know of all the type signatures of the functions. So let's imagine that this square is a string type. And we know that string.repeat2 actually accepts a string, and it returns a string. And string reverse also accepts a string and returns a string. So that means that those two can be combined together. And just because they can be combined together, we can do a double greater than operator and smash them in and create a new function. The result will be a new function. So this is quite cool. Now let's speak about types. The most basic type that we can imagine could be Boolean. Boolean is either true or false, right? Of course, Elm has Boolean built in. You don't have to define it yourself. It's not that barbaric. But here we just, to illustrate this example, we are going to show you how to do true and false. Me. This is say hello function that accepts a Boolean as our argument, and it returns a string. So every time we want to use a union type, we have to unwrap it. So meaning unwrap it, we have to cover all the possible cases that this type can be can appear in. So in this case, it's it can be either true, and then we return hello, or it can be false, and then we return I won't talk to you. Simple enough, right? So what if type contains some additional information, not just the type information itself, but like a payload? So let's say we have a name type, and someone comes into our application. He can be either anonymous or he can be present. Let's say he might have logged in, and we have a say hello function again, and the name argument is of a name. So name again is a union type consisting of anonymous or a present with a string. So string is the name of the person who is visiting us. Again, we unwrap it. If it's anonymous, we say hello guest, and if it's present, we unwrap it, and we actually get, with the help of pattern matching, we get this argument of this string. The usage is at the bottom. So if you say hello anonymous, it will result hello guest, and say hello present Jānis will result hello Jānis. So simple enough again. Tony Hoare, who is a principal designer of Algo 60, calls it his $1 billion mistake. Does anyone know what it actually is? Yes, thank you. So it's probably something that you have seen a lot, either like this, or like this, or like this, or like this. So null is a thing that actually represents nothing, right? So it was invented to represent nothing. And how does Elm solve this? Elm solved this by maybe. Maybe has a it sounds fun, right? So maybe has a generic type, meaning that maybe can be either nothing or just a specific type. And in this case, we have a show username function that accepts a maybe string and returns a string. So again, with the case statement, we unwrap it, and we if it's nothing, then we return the guest, and if it's just username, we return the username itself. So it's super simple, and yeah. You wanted the banana, but what you got was a gorilla holding the banana and the entire jungle. So that's a quote from Joe Armstrong, the creator of Erlang programming language. And of course, he talks about mutability and object-oriented languages. So the main issue with this code is that we don't actually understand what will happen with this user object, right? We know that it will probably add default last name to this user, but will it create a new copy of this data? Will it modify existing object? Or will it call like third-party service somewhere and return some sort of like other version of the last name? We don't know, and that's the main issue with most programming languages. It's really hard to reason about. The way Elm solves this is that if you modify some kind of data, it will return a new copy of that data. And Elm also has a notion of pure functions, meaning functions can't have side effects. So side effects are the things that, like HTTP calls, let's say, or for example, when you click a button and some event happens in the browser and then returns your result, all those things are considered side effects. And we're going to speak about side effects a little bit later, right? Because a world without side effects wouldn't be quite fun. It would just burn away processor power. All right, so what could go wrong here? Can anyone spot like four things that can actually go wrong with this code? Please go ahead. Yeah, basically default case, right? Visibility can be undefined. We don't know if it's undefined or whatever type it is. Visibility can be misspelled. Tasks can be undefined. Tasks might not contain an object inside of the array that has t.completed, right? You might misspell it, and for example, if you want to get completed tasks and you misspell it, you will get returned all non-completed tasks. Or so it's quite a challenge to work this and reason out. So there are a lot of potentially, like in this small piece of software, it's a lot of potential bugs. So how does Elm solve this? Well, let's say we have a visibility type that contains of all completed, not completed, and a task. It's going to be a simple task. It's either completed or not, right? It's a Boolean. So we have a filter tasks function that accepts a visibility and list of tasks and returns list of tasks. Just because Elm has strict typing, we won't be able to pass list of, I don't know, people or list of something else. So we always are going to be sure that when we call this function, we are passing the correct type into it. So again, we do unwrapping, and if it's all, we return tasks. If it's completed, we just filter out the completed tasks, and if it's not completed, we filter out not completed tasks. So what would happen actually if we have missing not completed case? Well, compiler to the rescue. So you might need to account for the following values. Main.notCompleted. Main is a name of a module we are currently located in. It says add a branch to cover this pattern. So it's easy, right? Quite easy to understand like what's going on here and how to fix it. Now let's do a little bit more tricky one. So let's say we have misspelled task.complete instead of completed. How would Elm actually react to that? So it would state that if you look at the last line, it will say, looks like a record is missing the complete field. Maybe it's a typo, completed. So it's quite cool, like it actually corrects for your mistakes. Like it can figure out by the way you, it can autocorrect you. Let's get this out of the way because everyone asks. That's the first question that everyone asks me. Like, so what will happen if you divide by 0? Well, basically you will get infinity. So what about side effects like this ugly monster from Star Wars? So let's say we have like some kind of event happening on HTML. Let's say someone clicked a button, right? It's the most classic one. So what we do, we send a message to Elm Runtime, and Elm Runtime actually returns to the update function. And the update function is responsible for modifying the state of the application, or in the other words, our model. So our model will get updated, and by the means of virtual DOM, like we do in React or mostly any other framework out there right now, it will regenerate the HTML. It's blazingly fast, right? So if we have something that is calling asynchronous data, it's gonna look the same. Basically, we will have on HTML, we have some event happening. Let's say we clicked a button to fetch something. It's going to be sent to Elm Runtime. Elm Runtime going to go to update, and update actually going to send a command back to Elm Runtime, and then return a message that it has been completed, and then the new model will get returned to the HTML. I know this sounds like a lot of work for just fetching something, but actually it allows us to write pure functions and just work with the data. And now I'm going to show you an example of HTTP call, how it's actually handled in Elm. So let's say we had called from our HTML a message get GIF. So this will get a random cat GIF. The type signature of update function is that it needs to return a model. So we are not changing in this case this model, we return it as is, but we send a command to Elm Runtime to say get random cat GIF. So get random cat GIF is actually sort of like an HTTP blueprint. We are basically stating to the Elm Runtime, please execute this following command. And if you look at the details of this function, it is a http.send command, and the new GIF is actually the message that we will receive once it's completed its thing. the second argument is in the parentheses is actual request itself. The interesting thing here is the decode GIF URL. So decoders are a way for Elm to convert JSON, loosely typed JSON structures to Elm strict types, right? And if there is no data image URL field, so we will fail. It will error out. So and then once we execute this function in Elm runtime get random cat GIF, we will get a new GIF message. So if we take a look at new GIF in the update function, we see that it's either okay with the new URL and we update our model, or it's an error. We don't handle that. I know it's a bad practice, but unfortunately we don't have enough space on the slide. So sorry about that. All right, so how does it integrate with JavaScript? Well, it integrates by the means of ports. So we can either receive things from outside world or send things to the outside world. And it's quite simple from the JavaScript side. You can just say app ports send model dot subscribe. So you're basically subscribing to anything that Elm pushes to you. And app.ports receive model is a port that will accept something from JavaScript. And you have to be careful here, because if you don't supply the correct types, it will blow up. So otherwise, it cannot ensure the consistency that it states that we are runtime free, right? So I know this looks kind of ugly, but this is how HTML looks in Elm. This is an excerpt from actual code that I wrote. So it does look ugly, I know, but you can get used to it. You get all the type safety guarantees of Elm with it. Of course, I think it could benefit from something like JSX. It's a little bit more readable, but then again, like, how do you apply semantics of JSX to Elm? And it might be tricky. So again, we can extract HTML parts into functions that do their own thing. Those can be extracted further to modules and things like that. So it's quite cool. So let's compare Elm with the React plus Redux, just because I'm mostly familiar with that one. So both have virtual DOM, both have unidirectional data flow. So the difference is that, of course, Elm is strictly typed and pure language, and JavaScript, well, that's JavaScript. Elm is immutable. You can get optional immutability with React plus Redux, for example, like with immutable.js, but that's also not going to guarantee you that you will not have any problems with it. So Elm doesn't have any direct access to DOM. The example is, for example, you need to get coordinates of the viewport. You cannot do that from Elm, so you have to reach for ports, unfortunately. But it's quite easy to do. Of course, React has access to DOM with refs, and yeah, it's not an issue. Elm has small set of libraries, but the thing with Elm is that if it's there, it probably works. So while React has like this vast ecosystem, you know, if the library is less popular, it's probably not maintained, and it's quite hard to sometimes figure out why something is not working. So with Elm, the situation is complete reverse. Like if it's compiling to the current version of application, current version of Elm, it's gonna work. So with Elm, you get no runtime error guarantees. So with React plus Redux or any JavaScript framework, really, you cannot get that guarantee. And the main pain point, I guess, with Elm right now is that it doesn't have any server-side rendering. I know the team is working on it, but it's still in progress, and how far is it, I don't know. So with React, of course, you have server-side rendering. It sounds like Elm is all roses and things like that. There are some problems with it, like a bundle size, for example. It's still being worked out, and it's definitely not a magic pill for everyone. Someone might not like syntax, but I swear you get used to it. It's quirky at first. So who's using it? Actually, when I prepared this presentation, I didn't know that we're going to be speaking at Tallink Hotel. So maybe you can ask around the staff how they are using Elm. I'm really not sure at what capacity these companies are using Elm, but as stated, they are. And the people who are using it actually, they report that it's completely runtime error-free. So anything that like if there's an error, it probably happens outside of Elm. I know that one company had like tens of thousands of lines of code with Elm, and they reported a single like runtime error exception that they got, and for that they created a special library to track it down, basically. So it's a rare occasion if Elm has any problems with runtime errors. All right, and I'd like to end this presentation by a quote by Max Kanat-Alexander, who is author of Code Simplicity. The difference between a bad programmer and a good programmer is understanding. That is, bad programmers don't understand what they are doing and good programmers do. Believe it or not, it's really that simple. So for me, Elm is a step towards the direction of understanding. And it's really that simple. Thank you.
So, time for questions. I know before there was at least one Elm expert here, so.
How do you scale? How well does it scale in a big application?
So what do you mean by scale?
How do you organize the code when you have 10,000 lines of code or more?
Well, basically, I don't think it's that hard. So, for example, you can have messages and a router set up, and it just basically has types for each page, and each page is a module. So it's, I'd say it's quite similar to what you would do with a React application, just more saner, I guess. Yeah, it's totally scalable. So, for example. You can take a look at the most complex open source project and you will understand it just because you know Elm, right? And it scales quite well, I would say. Like, you can follow the path and understand it. So.
Well, I guess that's it. Thank you.
Thank you.